Three-phase transformer winding connections. YY 0. First letter is for primary winding. Second letter is for secondary winding. 0 is for phase angle or phase difference between primary voltages and secondary voltages. These are the primary windings. These are the secondary windings. The primary connections are in star A1, B1, C1 and N1. These are represented in capital letters on one side of the primary windings. Other side of the windings are connected in star. This is the neutral point. Similarly, for secondary windings, A1, B1, C1 and N. These are represented by small letters on one side of the secondary windings. The other sides are connected in star. This is the neutral point. And this is the vector diagram of primary side. Here we are taking A1 as the reference. So from A1, B1 will be 120 degrees apart. C1 will be 120 degrees apart. The angle between B and C will also 120 degrees apart. This is for primary side. For secondary side, this is also star connection. Here also we are taking A1 as reference. From A1 to B1, it is 120. From A1 to C1, it will be 120. From C1 to B1, it will also 120. If we overlap these two vector diagrams, one on the top, then A1 and A1, these two directions are in the same direction and at same angle. So this is termed as YY0. YY6, primary is star connected, secondary is also star connected. So primary capital letters A1, B1, C1 and N on one side of primary windings. Other sides are connected in star. This is the neutral point. Similarly, on secondary windings, A1, B1, C1 and N are represented from other side of the winding because this is YY6 connection or the phase difference is 180. This is also Y180. So for on the secondary side, the difference has to be 180 means we have to take from other side of the winding. So if we take this is side 1 and this is side 2, this is side 1 and this is side 2. On primary side, we are taking out the terminals from side 1. For YY6 connection, we have to take terminal connections from not from the same side but other side. From other side we have to take. In this case, YY0 connection, this is side 1 connections, this is side 1 connections. So it is YY0. Here YY6 means we are taking connections from the side 2. So on secondary windings, the side 1 terminals are shorted and brought to neutral terminal. So coming to vector diagram, here also we are taking primary voltages as reference, A1 as reference. So from A1, B1 will be 120, C1 will be 120. The angle between C1 and B1 will be 120. If we take secondary side vector diagram, so we are taking terminals from side 2. Then here we have to take A1 as the reference, which is in opposite direction to the primary side voltage A1. So from here we have to take clockwise direction only. This is 120, 120 and 120. We have to take clockwise direction. So these numbers 0 and 6, these can be considered as clock numbers. Clock of 0, clock of 6, clock of 1, clock of 11. This 0 means we can consider as 12. When both the voltages of primary and secondary both are aligned in the same direction, that means this can be considered as 0 degree. Another case, if the voltage vectors of primary and secondary, these are aligning opposite to each other, then this can be taken as 6 o'clock, which is 180 degree apart. So similar kind of analysis can be done for DD0, DD6, DZ0, DZ6. So in DD0, primary winding delta connected, secondary winding delta connected, and the phase difference can be 0. Here primary winding delta connected, secondary winding delta connected, phase difference can be 180 or 6. So these are primary winding, side 1, side 2, secondary windings, side 1 and side 2. The terminals are brought from side 1, terminals are brought from side 1. These are the vector diagrams of both primary and secondary windings in delta connected. Similarly, DD6 case, primary winding and secondary windings, terminals are brought from side 1, terminals are brought from side 2. So the phase difference can be 6 or 180. In case of DZ0, the primary winding is delta connected, secondary winding is zigzag connection. The phase difference can be 0. For zigzag connections, each phase winding is split into 2 parts. This is only one phase winding, but the connections are different as per the diagram. So in this case, the reference of these two vectors is same or at 0 angle. In this case, the reference of these two vectors are in phase opposition or 180 degrees or DZ6. YD1 connection. These are the primary windings. These are the secondary windings. For primary winding, we have two sides, side 1 and side 2. Similarly, for secondary windings, we have two sides, side 1 and side 2. The connection diagram is YD1. That means primary is star connected, secondary is delta connected. This is the primary winding. The terminals are taken out from the side 1 and the side 2 terminals are connected in star connection. This is the star neutral point. This is the vector diagram. Here A1 is taken as reference, 120 degree, 120 degree and 120 degree. Secondary side, the windings are connected in delta connection, but the terminals are taken out from the side 1 only, A1, B1, C1, and the windings are connected in delta. That means side 2 of this one is connected to side 1 of next winding, side 2 of this winding is connected to side 1 of this winding, and side 2 of this connection is connected to side 1 of this winding. This is delta connection. Difference of connection from this winding to this winding is very minor. The difference of connection is, so A1 is connected to C2. In this case, A1 is connected to B2. So this is a very minor difference, but the shift of phase angle is either plus 30 or minus 30. If we follow these connections, then this will be YD1. That means the phase angle will be minus 30 degree. If we follow this connection, then the connection will be YD11. That means the phase angle will be plus 30 degree. So to check the phase angle difference from primary voltages to secondary voltages, we can use this shortcut method. So in this shortcut method, we will be drawing two vector diagrams. This is for primary and this is for secondary overlapped on primary. So the capital letter primary windings ABC, phase sequence will be ABC. Here we are taking A winding as the reference, which is at 0 degrees. On secondary, the phase sequence will be ABC, represented by small letters. These windings can be either star connected or delta connected. Here we have to check the phase angle difference. So here we are considering only delta connected windings. So delta connected winding means this is the winding A, B and C. Terminal 1, 2, B winding, terminal 1, 2, C winding, terminal 1 and 2. If we consider the connections YD1, then this will be the diagram. So from primary side, we are taking this A as reference. From secondary side, the connection diagram will be delta connection. So we have to follow the same phase sequence. With reference to this primary line A, we have to draw a secondary line A in parallel. After this, the secondary winding A, it will be having two terminal numbers 1 and 2. After this, again draw a line for capital A adjacent to this. This is must also be in parallel with this small a and this capital A. Why we are drawing this means we have to exactly find the type of connection, whether it is YD1 or YD11. If we are not sure, then we have to go for this kind of arrangement. We have to draw 3 lines. This is 1, this is 2 and this is 1. These two will be capital A, this will be small a. Now we have to follow the phase sequence ABC in clockwise direction. So this is A winding and this can be B winding and this can also be the B winding. This is phase sequence. This is also clockwise direction and this is also clockwise direction. So from the given connection diagram, we need to check the type of connections between A winding and B winding so that we can finalize the vector grouping of this transformer. From this connection YD1, the A2 is connected to B1. So this is A1 and this is A2. A2 is connected to B1. This will be B1. When A2 is connected to B1, this can be our triangle or delta connection. If we take the other case, whereas B2 is connected to A1, this will be B2. B2 is connected to A1. Then this can be our triangle or delta connection. So the delta can be LHS side delta or RHS side delta. If it is LHS side delta, then this can be our delta, and we already overlapped this primary voltage line or vector diagram on this triangle. This line has to be at the center of the delta. Then we have to check A1 of primary vector and A1 of secondary vector. Now we have to draw a line. This is our final reference vector grouping line. This arrow line indicates 1 o'clock. That means this is YD1 connection, which is lagging of 30 degree. That means secondary voltages are lagging the primary voltages by 30 degree. So this is known as YD1 connection or minus 30 degree. In the other case, if our delta connection triangle is RHS side triangle and overlapping of primary voltage at the center of this delta, now the reference line will be this. This is our reference line now. So that means this connection is YD11. That means the secondary voltages are leading the primary voltages by 30 degree. So in this way, we can analyze the type of connections and find the vector grouping of transformer so that we can find out whether the primary voltages and the secondary voltages are in phase or out of phase, or lagging 30 degrees or leading 30 degrees. So this is the total vector grouping of transformer. 0 means 0 degree, 6 means 180 degree, 1 means minus 30 degree, 11 means plus 30 degree. These are represented by clock numbers 12, 6, 1 and 11. So simply 0 means the secondary voltages are in phase with primary voltages. 6 means the secondary voltages are out of phase with reference to primary voltages or 180 degrees in phase difference. 1 means the secondary voltages are behind the primary voltages by 30 degree. 11 means the secondary voltages are ahead of primary voltages by 30 degree, that is plus 30. So simply remember this trick. This is very helpful for finding the vector group of transformers if the only winding connections are given. So this is capital A for primary, small a for secondary. Take these two lines in parallel. Next, check the type of connection between A winding and B winding. So that choose the type of triangle, RHS side or LHS side triangle. If it is LHS, then this is 1. If it is RHS, then this is 11. So this is total vector grouping clock diagram. We are taking horizontal line as reference. On the top side, we have 3 groups. This can be group 11, group 0 and group 1. At bottom, we have only one group, that is group 6. On the top side, we have to take same side terminals from primary winding and from secondary winding. If the connection is opposite case or YY6 connection or DD6 connection, so in that case, we have to take terminals from different sides. If we take terminals from side 1 of primary, then we have to take terminals from side 2 of secondary. So this is the case for phase difference of 180. So this is very important analysis. We have to follow these short tricks to find the vector grouping of transformer windings. So the same method can be repeated for different connections. PY1, PY11, YZ1, YZ11.